So let's apply this again. So we have here, we want to solve for the absolute value. So divide by -2, end up with that equation. Okay. Once I get to this part, the main idea then is when I undo this absolute value, I have to consider the positive situation. Okay, in this case, the positive domain will be when x is greater than 7. We're going to just do a testing here, so we're not going to deal with the domain at this point. So when in the positive domain, that means that x minus 7 is going to give us positive 7. That's our positive situation. And our negative situation is going to be when x minus 7 is going to be equal to the negative 7. Okay, so when the inside is equal to negative, we're going to have that scenario, and when the inside is positive, we're also going to have that scenario. We accounted for those both situations, so we can now solve this. So we end up with x equals 14. Okay, I'm going to test it. X equals 14. 14 minus 7 is 7. Absolute value 7 is 7. Times -2 is -14. Plus 14 is 0. So that's going to be good. So I'll just maybe -2 times 7 equals -14. Yeah, that's good. Okay, so solving the other situation here, I'm going to take away 7. No, sorry, add 7. So I end up with x equals 0. So again, we test x equals 0. If I plug it in, I end up with -2 times absolute value of -7 equals -14. Okay, well that's going to be positive 7 times -2 equals -14. So those are both valid solutions. They are not extraneous. Here, we have a variable on the outside. However, we still need to consider the same thing. Okay, so we have the x minus 4 absolute value. Well, that inside could be equal to the positive version of x or the opposite, negative version of x. Now, technically, we don't really know when we're talking about positive or negative. So this, when I say positive, really it's just to keep track of the fact that the inside is equal to positive, and it could be the x, it could be negative, because we don't negative of x, because x technically could be negative. Okay, but this is just a way of keeping track of it. So we'll do the exact same thing as we did before. We're not going to worry about that little detail because it's not really relevant to our solution. So the negative version is when x minus 4 equals the opposite of the x over here. Okay. So those are our two scenarios that we have to account for. Solving this, we end up with -4 equals 0, because I take away x from both sides. Well, is -4 ever equal to 0? No. So this is no solution. Okay. On this side here, when we solve this one, we end up with add x to both sides, we get 2x. Add 4 to both sides equals 4. Divide by 2, we get x equals 2. Okay, so we're going to end up with x equals 2, and we'll just check that solution. So we're going to test it. Test x equals 2. When I plug it in, I end up with 2 minus 4 is -2 inside the absolute value. -2 equals 0. Absolute value 2 minus -2 becomes 2 minus 2 equals 0. That is a perfectly valid solution. Okay, so this solution is our only solution. Now this is an interesting one, but we should really kind of check to see what it looks like. It's a little bit more complicated, so we maybe should graph this and just kind of see what this looks like and see that it actually does work, that x does actually equal to 2.